Hi, my name is Chu Bing. My number matrix is RA25171, and I'm going to present our fluid mechanic workbench project. And the title of our project is Hybrid Water Supply Piping System and Moscow. Next, I'm going to introduce myself and my group member. So I'm Chu, number matrix RA25171, and I am the group leader of this project. Next, for my members, Noor Umara, RA25168, and the other member is Jeko Aisha, number matrix RA25170.
Hi, my name is Nur Omara and I'm from RA25168. Okay, today I'm gonna explain about our work-based project about the piping system. The introduction is a piping system is very significant in ensuring efficient and safe water distribution in a building. For public establishment like a surau, a functional piping system is needed for supplying clean water that is essential for various activities such as washing and sanitation. The design of a successful piping system ensures a constant supply of water while promoting cleanliness and public health. The report deals with the design and functioning of a clean water distribution system for a surround that use as well as the primary source of water with a storage tank for distribution of the water. It includes filters, control valve, and water pumping system for ensuring that the distributed water meets basic cleanliness standards. Through the analysis of this piping system, this research aims to assess its efficiency, functionality, and aptness for use in public spaces. The results of this research will shed light on how piping systems should be laid and maintained to optimize water distribution efficiency and religious at public structures such as church and mosques. The objective is to study the design of construction of the clean water piping system used in the surau. To determine the main components of the piping system include pipe, valves, pump, filters, and storage tanks. To analyze the water distribution process from the well source to end user points such as ablution taps and toilets. To evaluate the efficiency and reliability of the piping system in supplying clean water continuously. Lastly, evaluation for the suitability of the system for fulfilling the requirements concerning the hygiene and water demands for public utilization. The description of selected system. The first one, intake of water, suction phase. While water, there will be a pump, which is of a submersible nature, and immerse or a jet pump, which is a surface pump. This pump sucks water from the bottom of the well. The water is then forced into the pipe. Then, tank water. Water comes through the main pipe coming from the water company into the storage tank in the tower. When the float goes down, it is automatically topped up with water. The second is filtration and treatment stage. This is the most critical part of the water from a grave well because in most cases, there is always an accumulation of sand filter. This filter removes coarse particles of sand and salt. Carbon filter. This removes the smell and the clarity of the water is restored. Chlorinator. Some surau have a small chlorine drip system that is used to eradicate bacteria before the water is distributed into the internal system for health reasons. The third is distribution phase. The system utilizes a manifold, a central distribution point to split the water. One-way system, well pipes and tank pipes cannot intermix directly. Check valve mount on each path is function like a one-way door. For example, well water can enter the toilet tank, but the water cannot push into the ablution pipe that uses the main tank water. This is to make sure that the purity and cleanliness of the ablution water is maintained. The fourth is emergency system if the main tank water is disconnected. Management of the surau could open the special butterfly valve or gate valve which connect well water that has been filtered to the ablution channel. This ensures that the surau will not be without water for the congregation to pray even during disturbance in the government water supply. Okay, the water demand description by section. And in the toilets, type of use is toilet, flushing, and hand washing. The estimate water consumption is 10 to 12 liters per person. The daily frequency is 1 until 2 times. Estimated the total is 15 to 20 liters a day. Water source is from well water. The ablution area is the ablution before prayers, 4 to 5 liters. The daily frequency is 3 to 5 times, and the estimate total 15 to 20 liters a day. The water source is main storage tank. At the water filter, drinking water is used. Estimate water consumption 0.5 till 1 liter per person. The daily frequency is 1 time. The estimated total is 0.5 until 1 liters a day. The water source is filtered tank. The explanation of water demand area. The toilets. In toilets, water is used for flushing toilets, hand washing, and cleaning. In this use, since drinking water is not required, filtration of water from wells is adequate. The water consumption is, however, higher because of the large quantities of water required in flushing toilets. Toilets, therefore, contribute greatly to water consumption in Suraus. Second, ablution. The ablution area is the most important area because it deals with purity and cleanliness of water. An estimated 4 to 5 liters of water is used per worshipper per ablution. Water usage in this area is high because of the high frequency of ablution, particularly during congregational prayers. Water normally comes from the main tank that is supplied by the water company to make it safe for use. The last one is water filter. The main use of the water filter is drinking, and the level of use is limited. Not all devotees use this service, and the use of water is less compared to other areas. However, it is necessary to install a filtration system to provide safe and quality drinking water.
Next, this is a project AutoCAD overview. For the piping system and the tank, the total dimension have been calculated. The total length of 120 mm diameter pipe is 158.3 meters wide. The total length of 16 mm diameter pipe is 33 meters. In terms of fitting, there are 9 holes used in the system. The total number of elbow joints is 18. There are 3 T-joints installed. This quality represents the copy piping layout for the system. And this 2D view, and this side view, and this top view. For this slide, I will explain Bradley equation. Bradley equation describes the relationship between pressure, velocity, and elevation in a flowing fluid. The equation is P over rho g plus V square over 2g plus V equal a constant. In the project, Bradley principle is applied to analyze the water flow from the elevated storage tank to the ablution area and toilet. The height difference between the tank and the outlet creates pressure. Because of the pressure, water can flow naturally without the need for continuous plumbing. This helps to improve efficiency and reduce energy uses in the water supply system. Next, I will explain the continuity equation in fluid mechanics. The continuity equation is used to ensure conservation of mass in a piping system. The equation is A1V1 equal to A2V2, where A is the cross-sectional area of the pipe and V is the flow velocity. This theory is applied when the pipe diameter changes. When the pipe diameter becomes smaller, the flow area decreases. As a result, the flow velocity increases. The increases in velocity help to ensure that enough water is delivered to the outlet. Therefore, the continuity equation is very important in designing and analyzing piping system. Next, we apply the concept of the Reynolds number to our system. The Reynolds number helps us determine the type of flow occurring in a pipe, whether it is laminar or turbulent. It is calculated using the formula RE equal rho VD divided by MU. In the system, the water flow is mostly trivial because of the moderate flow velocity and the size of the pipes. Trivial flow is beneficial because it improves mixing, which is important during filtration. However, it also increases friction loss. This loss must be considered carefully when solution pipe and pump to ensure efficient system performance. As another important theory applied in the system in heat loss. Heat loss occurs due to friction between the fluid and the pipe wall, as well as loss from pipe fittings such as valve, and filter. To estimate hair loss, we use the Tracy-Weisbach equation. Show her. This equation always has to calculate the energy loss of the flowing water as they move through the system. By applying this theory, we can accurately determine how much energy is lost along pipe, valve, filter, and bin, which is essential for proper pump sizing and overall system design.
So, for the 4.5 that is pump power, it showed that pump theory is applied to ensure sufficient energy to lift water from the well to the storage tank. So, in this theory, the formula that is P equal to H pump times rho GQ divided by EM. The pump must be overcome elevation head and friction losses to maintain continuous water supply. For the calculation, the first step is we need to find the velocity. So we will assume the Q is 4500 L per minute and we will transfer it to the meter per second square. So the value is 0.075. And we need to find the velocity 1 using the 120 millimeter for our diameter, and we key in the value on the formula, so we will get 3.32 meter per second. For the velocity 2 is also same step like the velocity 1, and we just change the velocity and change the diameter, that is 60 millimeter, so we will get 30.26 meter per second for the velocity 2, and we need to find the RE, so we will using the formula that's equal VD or dividend U. So uh, the formula is 1000 times 3.32 and times the 0.12 and divided by the 1.75 power of negative 3, so we will get 227,657 and 0.14. So this, because our RE is bigger than 4000, so this pipe this pipe is a turbulent flow, so we also need to calculate the friction force. So the friction force is 64 and over the RE, so we will get 2.81 times 10 power of negative 4. Because of our friction force is difference of our appendix, so we will refer the appendix value, that is 0.016 for our friction force. So next we will calculate the major and minor losses. The formula is HL equal to K times V square and over 2G. So we first will calculate the 100 millimeter diameter for the pipe. So the entrance of K value is 0.5 and the velocity is also same 3.32. So we will get the value is 0.28 meter for the entrance losing, and for the elbow losing the K value is 0.9, and we have 40 elbow, so that is 7.08 meter. For the WAF, the K value is 0.8, and we have 8 WAF, so the answer is 2.25 millimeter. So for the T joint, the K value is 0.3, and then we have 3 T joints, so the answer is 0.51 meter. So for the 120 millimeter pipe friction, so we were using the friction force 0.016, and bracket, the total length of the pipe is 153.x times the 0.12 and times the velocity square, so and over the 2g, so we will get 0.17 meter. So for the 60 millimeter diameter, the elbow is the elbow we have 4, so we need to times 4, so we will get 32.26 meter for our elbow in 60 millimeter. And next for a wave waf in 60 millimeter, we only have one waf, so the answer is 4 by 4x meter. And we need to find the 60 millimeter in pipe friction, so it's same like the V, and but we have different total length, that is 33, and different velocity, that is 30.26, so we will get the answer 2.84 meter. So for the total energy loss is 0.28 plus 7.08 plus 2.25 and plus 0.51 and plus 0.17 and plus 32.26 and plus 4.48 and 2.x4. The answers will be 49.x7 meter. So for the last calculation, we need to find the total loss after we modify with a water pump. So we using the formula is power equal to H pump times rho GQ over EM, and we will assume a value, some value, that is P equal to 6,000 volt, EM is 6, Q is same like our previous calculation, that is 0.075, and we key in the info to the calculation, and we will get H pump is 48.93 meter. So for our final total energy loss, we will using the before we don't using the water pump, and to minus our after modify the water pump, so that's 49.87 minus 48.93, so our system, the total energy loss is 0.94. Next, I'm going to present energy loss analysis. In 6.1, major losses occur due to friction along the length of straight pipes. Longer pipes and smaller diameters increase friction loss significantly. 6.2 is minor losses. It occurs due to elbows and bends, valves such as gate, butterfly, and check valve. The third thing is filters and fitting. These losses are significant due to multiple components in this system. 6.3, that's a factor affecting friction. In this part, we have 4 points. The first point is pipe roundness. The second point is flow velocity. The third one is pipe length and diameters. And the last one is type of fitting users. On the other hand, recommendation to reduce losses. In order to optimize the efficiency of the system and avoid losses of energy, it is recommended to consider the following. Cross pipe with a bigger diameters can be used to decrease the rate of flow, reduce the number of plants and connection to a minimum in piping arrangement. The third one is using smooth pipe materials such as PVC to reduce friction factor. Next, install a efficient water pump with appropriate head and flow capacity. The last one is carry out filter and valve maintenance to avoid blockage. Such measures will help decrease the losses of head in the system and also help extend in the life of the pipe network. In conclusion, the research has been able to analyze the proposed water piping system that is used for the well, comprising a well water system and elevated storage tank as the main sources. This is despite the fact of the system comprising the elevated storage tank is the main sources. On the basis of analysis, the aim and objective of this study have been achieved. The layout of piping system and its various components such as pumps, filters, valve, and storage tank have been discussed and their uses also elaborately described. The theory of fluid mechanics, such as continuity equation, Bernoulli equation, Reynolds numbers concept of head loss and pump power concept have been described to make a understanding of water flow and pressure phenomena. Results indicate that the system is able to provide adequate water for flushing into the toilet, the ablution area, and the water filter unit. However, there are some losses that are experienced in the pipe due to friction and fitting, especially where there are several value embeds. Suggestions that would help improve the efficiency of the system include the using of correct pipe size and minimizing unnecessary fittings. In conclusion, the piping system that has been identified is appropriate to be used in a surround and satisfies the basic demand as well as the health aspect of water. The system with a few upgrades will be more efficient and reliable, hence providing constant water whenever the believer needs. Furthermore, for the reference, the first one is Introduction to Fluid Mechanics edition and it is from Fox and McDonald. The second one is Fundamental of Fluid Mechanics 7 edition and it is from Alexis Forrest. And the last one for the Applying Fluid Mechanics 7 edition, it is from Robert. So this is the appendix we're using on our calculation. The first one is find the energy losses in pipeline. The equation is HL equal to F times LV square and divided by 2GD. So for the entrance losses is HL equal to K times V square and divided by the 2G. So how to find our value K? That is LE divided by the D and times the friction force. So when we need to find our H pump, we need to using the power of the pump. So the equation is power equal to H pump times rho G cube and divided by the EM. Furthermore, I'm going to present the appendix for the piping system. The first one is the dimension for the black pipe with a diameter 60 millimeter. So you can see the total length for the black piping system is 33,000 millimeter. For the brown pipe, it has diameter with 120 millimeter and it had 153.8 meter for the total length. The last one dimension for the piping system is 6,000 volt of the water pump and it has the length around 2,000 millimeter.